So now whatever we discussed, that is continuous CDF means say continuous random variables. So we discussed about continuous random variable and the CDF for that. Now for discrete random variable, the CDF for discrete random variable, the CDF can be written. So let's say we have a set of we have a x is the discrete random variable, and xi, that means x1 x2 dot 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 xi are the values of discrete random variable which we can take. So then CDF of discrete random variable can be written as fx of small x will be equals to summation of I is 1 to k px of xi for xk less than equals to x less than equals to xk plus 1. Now try to understand what it is the meaning. So fx of x, where x is in between, that means we have some random variable x1 x2 x3 dot dot dot, let's say xn or xk, and it will go further. Okay, so now at any point, what is the fx of x, small x? That means if x is in between xk and xk plus 1, then this will be the sum of probability of all x. Okay, sum of probability of all x. That means if x is here, we need to do sum of probability up to xk, x1 probability of this plus probability of this plus probability of this, all these together if we sum, then we'll get the fx. So similarly at every point we will do like this and we get the fx. So this is basically the fx we received from the probability mass function. So now this condition we could remove by using the step function. So or alternatively we could write fx of small x will be equals to I equals to 1 to k, then px of xi u of x minus xi, and this condition no need to write. How it is possible? So x minus xi means when xi is x1, that means we got at x1, below that it will be automatically 0 masking, and if it is x3, x minus x3, that means if x is below x3, x1, x2, it is automatically 0, we'll take x3. That means always we'll take up to 1 to k, and it will be x1, it will be x2, just rough I am trying to write, it is just for simplicity. It will be equals to px x1 u of x minus x1 plus px x2 u of x minus x2 plus like this. That means when we are masking this, so we got this number plus probability of this number plus probability of this number, like that we got. So this way we could remove this condition. So we can write this is the CDF. So CDF we derive from the PMF, probability mass function. That means we know all the probability. So probability mass function 2, we derive the CDF of the discrete random variable. Okay. Now tell me if it is fine or you have any point to clarify or any question. Please tell me.
It's fine, sir.
Okay. All of you? So, or
Yes.
you need clarification how the unit step we must to get the PDF. Is it okay? You are not speaking. Hmm?
Yes, sir.
Okay,
Yes,
fine.
sir.
Satipriya and Shreya, is it
Yes, sir, it
fine?
is okay.
Yes, sir.
Okay. So now next we'll move as the probability density function. So all of you know this is some kind of recapitulation 1.2.2. So 1.2.2 probability. This is very important. CDF we generally in our stochastic process we don't use much, but probability density function we use maximum. And whenever I ask some question in interview or something, it seems that the student knows, but there are some misconception. Probability density function. What is that? We call it PDF. Okay. So we come PDF probability density function from the CDF. So CDF, from CDF we could come to PDF. How? Generally we define like that. Later we don't need to do it, but in definition we do like this. So definition what we could write. So the probability density function PDF of a random variable x at the point small x is, we call it small f. Okay, always this is very standard thing. Fx will be equals to limit epsilon tends to 0 probability of capital X in between small x to x plus epsilon divided by epsilon. What does it mean? It means just derivative. So we take the probability in between x to x plus epsilon, divide by epsilon, and limit epsilon tends to 0. So it is for a, so we could tell it very clearly. So fx, so this is the definition, but we can still further derive fx of small x will be equals to limit epsilon tends to 0 probability of in this between. What does it mean? Probability of x remaining in between x to x plus epsilon,
C
that means
CDF of
yes,
X plus
CD,
epsilon.
CD, yes, CD. Just I am writing one more step, x plus epsilon minus fx of small x divided by epsilon, and it will be definitely d of fx of small x by dx. That means if we make derivative of CDF, we'll get the PDF. Okay, so definitely we could write that PDF of a random variable is the derivative of CDF. Okay, so for CDF you make derivative of it, you will get PDF. Okay, this is fine, everybody knows it. We need to go a little bit more properties, which is very much helpful and will give some more insight. It is fine that if we derive a derivative the CDF, we will get the PDF, but some properties let's discuss and we'll go more. So properties are more important. Sometimes if you learn properties, you will get more insight. For example, fx of small x, that means the CDF will always be greater than or equals to 0. How it is coming? So if it is a, we said that it is a monotonically non-decreasing function. So if it is a monotonically increasing function, fx will be, slope is always more and more. So fx will be greater than 0. And when it is not decreasing, that means the CDF is constant, then fx will be 0. So fx could be either 0 or it could be more than 0. And next properties, it should be written fast, but anyway, so this will be the derivative of CDF with respect to small x. Now, point 3, this is also very important. How do we get CDF from PDF? So fx of x will be equals to minus infinity to x. If we do integration of CDF, we'll get, sorry, if we do integration of PDF, we'll get CDF. Okay. Now, what will be the area minus infinity to plus infinity fx of small x dx? It is 1 because the area under the curve is the probability. So if the full curve we consider, the probability will be 1. Now next is a to b. How do we get the probability of getting a to b? X dx will be equals to the probability of, or probability of a in between x to b. So to getting what is the probability of random variable being a to b, that is the integration of fx. Now let's see, arbitrarily let's draw it. Suppose we have a x here, we have a fx here, pdf, okay, and let's say we have some arbitrary density function like this, okay, x fx. So this is the arbitrary PDF on PDF probability density function. Now let's try to see that here fx will never be monotonically increasing or decreasing. It can be anything, okay, it can be increasing, decreasing, fixed, no issue. Next thing is that if we fx will always be 0, it cannot be negative, okay. The next thing is that suppose we want to know the probability of probability of random variable, say a to b, what you will do, you will do the integration so that the integration area under the curve will be the probability. So y-axis is not the probability, y-axis is the probability density, always I am saying. So fx is probability density, not the probability. So in some question, if I ask this, 95% student says that fx is the probability. This is wrong. Fx is not the probability, fx is probability density. Why it is density? Because if you integrate fx, you will get probability. So fx is not the probability, it is the density, because if you integrate fx, you will get the probability. That is why it is called the probability density function. So you listen it properly. So I am emphasizing this because whenever I ask this, 95 to 98% student says that fx is probability. So fx cannot be probability, but if it is a discrete, then it becomes probability mass function. That I am coming later. But in continuous, fx is probability density. That means if you integrate fx, you will get the probability. So y-axis is not the probability, it is probability density. To get the probability, you have to integrate. This is the first point, you have to be careful. Next point, generally we ask the value of the fx. Can it be negative? Definitely no, because fx comes from CDF. CDF is monotonically non-decreasing function. If you make derivative of it, it will be always positive or 0. So fx can be 0, fx can be positive, so fx cannot be negative. This is the second point. This also people fail to answer. Next is the value of fx. Can it be greater than 1? Okay, what you says? Anybody has any view? Please answer.
It can be greater than 1.
Okay, anybody? Any other student? Just express your view. See, whatever you said, it is correct. So if fx is not the probability, there is no harm if it goes beyond 1. But the integration when you do on the fx at any interval cannot be beyond 1, because the integration is a probability. Probability cannot be beyond 1, but probability density can be, because it is the probability density, it is not the probability. But if we integrate fx to any limit, the integration cannot be more than 1, because the integration is the probability. But if we take the fx and we say that it can be more than 1 or not, there is no restriction, but integration cannot go beyond 1. Okay, is that fine to everybody?
Yes, sir.
Yes, sir.
Okay.
Yes.
Okay, so now
Yes,
you
sir.
tell me the PDF, the concept of PDF, do you understand properly? Because this is the whatever I am teaching. So this PDF will go up to the end, and maybe in if you count the word in every class, the most used word will be PDF. Okay, that's what I am emphasizing here. There should not be any misconception on PDF. Is it fine, all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now let's say one example. Can fx x say 2x e to the power minus x square 2 from where it is 2x e to the power minus x square ux. So can it be valid PDF? A valid PDF? What do you say?
Sir, probably no, because its integration is would be greater than unity.
Why integration will be greater than unity?
Because ux is actually, sir, kind of a ramp signal. It's
Ux is
showing.
unity function. No, no, ux is not ramp signal. Who said ux is ramp signal?
No,
Ux
sir,
is
x
unity
ux.
step. X is ramp signal, but e to the power minus x square is sharply decreasing. So if x is infinity, okay, or x is very large, what will happen?
So it will be 0. Yes, sir. 0.
0. Then why not? It is not unbounded.
Yes, sir. Yes, sir. Yes, sir.
Okay,
It would
then
be.
tell me, would nay it is or is not?
It is a valid PDF, sir.
Okay, fine, very good. So to see the valid PDF, we need to do few things. First thing is that whether it is normalized or not, that you have to see, right? So for that we need to see that minus infinity to plus infinity fx of small x is unity or not. Can you check it? So if it is ux, that means we need to go 0 to plus infinity 2x e to the power minus x square dx, right? 0 to infinity 2x e to the power minus x square dx. So is it unity?
Yes, sir, it is unity.
Yes,
Okay,
sir.
so then this is the one point. Yes. Second point you need to check. Second point is the function is negative or non-negative. Is it always greater than equals to 0?
Yes, sir.
Yes, sir.
Yes,
Yes.
sir.
So yes. So it is a valid PDF. Fine. Now let's see fx small x will be equals to 2x e to the power minus x square ux is a valid PDF. Now can you tell me what will be the CDF of it? That means fx of small x, what it would be? Do it. We know that the conversion. How do we get capital F? This one, 3.3. So one thing I'm saying, so I'm writing it. So if you want to engage yourself more, what you can do, you can write with me. Anyway, this recording and everything will be there. But still, if you keep on writing, you will be more engaged and more transfer will happen. This I tell almost everybody, as if I'm writing in board and you also write on your notebook. So writing in board and when you are in class, if you write in your notebook, if you even get the board and all the things, slides and recording, still if you write it, you will be engaged more and you will be more habituated and more contact will be there. So that much I feel. Okay, you also try to do it. Keep on writing on your notebook instead of listening it only. Okay. So you see the point 3, capital X will be this one. So we know the small f. What will be the capital F? Quickly calculate. Point 3 you take.
So it will be 1 minus e raised minus x square.
Right. So if we do it, capital Fx small x will be equals to minus infinity to small x fx of y dy will be equals to minus infinity to x 2y e to the power minus y squared uy dy. So this will be equals to y to the power minus square uy dy. So this will be equals to ux uy will be ux, so it will be 2y, 2 will go, 2 will come, so 1 minus e to the power minus x square ux. Is it so?
Yes,
This one
sir.
you said, na? Okay.
Yes, sir.
So this is fx. Everybody agrees? Please tell me if everybody
Yes,
agrees.
sir.
Okay.
Yes, sir.
Okay. So now another example. Suppose we have a random variable with PDF. Fx of small x will be equals to a e to the power minus x plus 3 whole square by 8. Okay. So for fxx be a valid PDF, what will be the value of a? Do it. Doing right?
Sir, is it a square root of pi divided by 8? Oh, sorry, 8 divided by pi.
Yeah. Tell me 1 by a equals to
A is equals to, sir, square root of
this
pi
one you say.
divided by 8.
This one you say.
Yes, sir.
1 by square root of 8 pi. What other says? Doing? This is correct. Joyce, how you did? That integration you did.
Yes, sir. Actually, sir, I had remembered that integration of e to the power
Yeah.
minus x squared dx is equals to square root pi.
Yes, that yeah, otherwise, yeah, tell me. Minus infinity to plus infinity to the power
Minus
minus
x square.
square dx will be equals to
Square root of pi.
correct. Otherwise, it will be tedious to integrate. Okay, other people take this help and quickly go ahead. So basically, solution will be minus infinity to plus infinity fx dx will be 1, or a minus infinity to plus infinity e to the power minus x plus 3 whole square by 8 will be equals to 1 dx, and this we have to solve to get the a, right? And what Joyce says, e to the power minus x squared dx will be equals to square root of pi. So you take help of this and you will see that what is the value of this will come, and a multiplied by that value will be equals to 1. Okay, so maybe that will come square root of 8 pi or something.
So,
Yes, sir, it is
there,
coming.
so there is
Yeah,
one more statement like minus
tell
infinity to
me.
infinity. E raised minus lambda x square dx is under root pi by lambda. So with that help
Pi
only
by
we can do
lambda. So it
the
will be pi by 2 or something.
So if we put lambda before x square in the integration, then the
Ah.
answer will be under root pi by lambda,
So
whole
what
under
it
root.
will be this one?
So same answer only it will be.
Same answer, na? Lambda is 1 here, na?
So lambda is 1 by 8 here.
1 here 1 by 8 in this case I am saying.
Yes sir, yes sir, yes sir. In this case it is 1.
Hmm. So yeah, so all of you get A, na?
Yes, sir.
Okay. So now you see that so normalizing is a big constraint, and it should be, because the probability will be unity, all the probability, right? So now can we proceed? Everybody is okay. Okay means are in the same platform, so that we can proceed further.
Yes, sir.
Yes, sir.
Okay, Ramsam, you are not saying anything. Ramsam is there.
Yes, sir.
So you are not saying anything.
No, sir, I
Are
got
you
it.
following?
Yes, I'm following.
Okay, fine. Okay. So if any query you have, you just tell me. Okay.
Okay, sir. Yes.
So I forget that. Anybody else? I am not calling by name. Just let me see. Kirti, is it fine?
Yes, sir, it's fine.
Okay, so that A and all got it?
Yes, sir.
Okay. Okay, fine. Then I think everybody I'm calling, right? Anybody I'm missing? NR is whose name?
I am in Ramsai.
Okay. So, are you following?
Yes, sir.
Okay. So somehow, oh, you are Ramsai only. Okay, N is okay, fine. Okay, what about Satipriya?
Yes, sir. Clear.
Are you following it properly?
Yes, sir.
Okay, clear. Okay, fine. So now the maybe the popular example of continuous PDF is Gaussian random variable, right? So, Gaussian random. This we will revisit again and again. So for the time being, we are visiting it for a single random variable. Then gradually we will go for multiple random variable, and we will revisit more and more times. So for a single random variable x, the probability density function fx of x, if it is 1 by root 2 pi sigma square exponential minus x minus m square by 2 sigma square. Okay, if our probability density function or fx follows this kind of expression, so it is called the Gaussian random variable. Okay, so here we have two parameters, one is m and one is sigma, right? So if we have m and sigma, what is the meaning? M is the mean of the random variable and sigma is the, tell me, standard deviation of the
Deviation.
standard deviation of random variable, right? And sigma square is the variance. Standard deviation square is variance. So it is two parameter distribution, m and sigma. M is the mean and sigma is the standard deviation. So what is the meaning of mean? Same meaning. So whatever you have the random variables, you take all the random variables. So you cannot take it as it is a continuous, you cannot take all, but you take many random variables, and then you do average, you get in. You take those random variables, you do the standard deviation, you will get similar to sigma. So A is the average random variables, my standard deviation of the random variables. So random variables here could range from minus infinity to plus infinity. So you take those many random variables. So to do so, you need to go continuous domain. I am not discussing how you can do it, but in discrete domain, suppose this Gaussian distribution you are approximating with say 10,000 points and weights. So then you take 10,000 points, make mean of it, you will get very close to m. You take 10,000 points, do standard deviation of it, you will get sigma, very close to it. And this random variable, this probability density function PDF will be 1 by root 2 pi sigma square e to the power minus x minus mu or m square by 2 sigma square. So if you plot it, how do you get it? So if m is 0 and sigma is 1, we call it standard normal distribution. It is a special case. So if you plot it x versus fx, if you plot x versus fx, okay, so you will get something plot like this. It is a bell-shaped curve, always we used to say, where the peak will be at mean m and standard deviation will be, So now if another curve you get Gaussian distribution where fx of x is there, similar mean is same, but it is very sharp. That means, oh my god, that means here m. So if this is sigma 1, if this is sigma 2, sigma 1 is greater than sigma 2, because if your standard deviation is more, the points will be spreaded more and you will get more flat curve. If standard deviation, if standard deviation is more, if standard deviation is less, you will get very sharp curve because the points are very close to each other. Sigma 2 is less. Yes, this is fine. So now there are few other points. Suppose your aim is different, so then this peak will shift. So this Gaussian curve peak comes at m mean, and this width or the flatness depends on the sigma. This is a 2-parameter curve. So this curve is very popular because most of the physical phenomena, uh, be it the velocity of the gas molecule, be it be a number of the students in a class, mostly for. So this is what PDF of it, and then CDF will be kind of S kind of curve, and this is a single dimension. So x-axis we plot the random variable, y-axis we plot the probability density function. And how do we get, suppose I say that what will be the probability of getting a random variable in between minus infinity to say x equals to 1. That means you integrate it minus infinity to x equals to 1. This will be the probability of getting this. Okay, so if I say what random variable from the Gaussian distribution from x equals to 1 to 2. So x equals to 1 and x equals to 2 you take and you integrate over this curve, you will get the probability. So these are all the physical interpretation. So very briefly if I say, so this will be like this, and then if we know this probability, this half probability will be 1 minus this, because the full probability will be unity. And you know that if it is a very sigma, if sigma is more, the flatness will be more, sigma is less, flatness will be less. And if we integrate in between through the mean plus 1 sigma to minus 1 sigma, something 60% or something will come, and then if you integrate 3 sigma, it's more than 95% we get. So the tail probability is very less. The probability near the mean around the sigma is more. This is what its physical descriptions. And there are many other different PDF, many different PDFs, hundreds of PDFs are available, and those are also expressed by some equation which has the which follows the properties of the PDF, and we don't go by that. Whenever it is coming in your study or just read any such PDF, right? You know the such distribution. So we'll not go through it because all the distribution follow the same property, and you will see that only the expression you need to remember and few other physical expressions. So maybe uniform distribution you could read. Now tell me, this Gaussian is the most important. So is it fine, or you have any other query? You must have, you should have, because this Gaussian distribution is more and more important. Tell me. All of you know it, and also you work on mostly Gaussian distribution. Still, anybody wants to say anything? Is it fine to everybody?
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Okay. So now just quickly we'll see the uniform distribution. This interpretation is nice. We will come more and more with the interpretation when multidimensional Gaussian distribution we'll see will come more and more. So for the time being, this. So now let's see uniform distribution also very popular. Uniform random variable. So the PDF is defined as equals to 1 by b minus a, where a is less than b and 0 elsewhere. So it means that if we want to draw it, so x versus a, b, and AB, so area should be unity now, so this will be 1 by b minus a, then 1 by b minus a into b minus a will be unity. That is what it is, the constraint. And what will be the probability cumulative density function, CDF? So that will be fx of x will be 0 x minus a by b minus a 1. 0 will be 8 from a, it is starting if less than a. This will be in between a to b, and this will be greater than equals to b. Capital X, sorry, small x we plotted. So it will be fx of small x. It will start from A, and at b it will be, and after that it will keep on being unity. So this is the CDF of it. This is CDF. This is PDF of uniform distribution. CDF of uniform distribution. Okay, so what we learned today? So today we learned many things, starting from PMF. We learned Bernoulli's, we learned Poisson, we learned what is CDF, we learned what is PDF, we learned what is discrete PDF, that is also important. We learned what is Gaussian distribution, we learned what is uniform distribution. So today we learned many important concepts which are very frequently used. So this is a kind of recapitulation. The next thing we'll move is the conditional distribution. Now conditional distribution also you might know or you may not aware of. Conditional distribution and density function, that is also very important. And we mostly work on the condition. Tell me if any query you have till this point. Is it fine to all of you? So any comment or anything you want to give regarding the class? So I can take that feedback quickly. If any modification or anything you want. This writing and speaking is fine, right? All of your computer or mobile, it is going with synchronized way, right?
Yes, sir.
So this is what I found. This Skype, it is fine, but other software, it never happens. So I need to take some other means. So this is the thing I like to write and speak, so that it is a kind of class. We can think about that. Okay. Now we'll move to conditional distribution function and conditional density function. Okay. This is very important at this point because we work on conditional thing, that is very required. So let's define it. So you are not tired, right?
No, sir.
Okay. So 1.2.2. So 1.2.3 conditional. Tomorrow, what is your schedule? So 5 to 7 you are free. So let's fix a class 5 to 7. So probably I would be available 90%. If anything happens, now we have WhatsApp group, I tell you. So let's fix a class tomorrow 5 to 7. Okay. So if I am not available, I can send one message to WhatsApp. So this kind of uncertainty will go for few weeks, maybe 2 weeks or something. Then we can freeze everything prior. Okay. So little bit you have to accept this. Okay. Now this is a new section I am going to start. This is conditional. Very important. Conditional distribution and density function. Okay, you might be because conditional I don't know. In 10 plus 2 is it there? Conditional distribution? 10 plus 2 syllabus?
Yes, sir.
Okay, it is there. Okay, it is fine. Okay. So the conditional cumulative density function, distribution function, sorry, the conditional CDF of a random variable x condition on the event A has occurred. So that how can write? F is the CDF of x condition A has already occurred at the point small x will be equals to probability of capital X less than equals to small x given that event A is occurred, that is kind of probability of A comma B. So that means it will be equals to joint probability of P of X to event X less than equals to small x comma A divided by probability of A. Okay. Now all of you tell me whether do you agree this or not. This is the fundamental definition. If you agree this, we can proceed very quickly. Okay, so this is the fundamental definition of conditional CDF. That means the CDF of X conditioned A. That means the probability of X less than some value small x conditioned A. That means the joint probability of X less than some small x comma A divided by A. So we are using this thing that probability of A condition B will be equals to probability A comma B divided by probability of B. That's what the same formula we are using here. So is that fine to all of you?
Yes, sir.
Okay.
Yes, sir.
Done some?
Yes, sir.
Is it fine? Okay.
Yes, sir.
So you have done some course earlier or this is the first course?
In BTech, it's there's one part.
Okay, fine. So now if this is the definition, so here one thing I did not say but I should say it. It is obvious that the probability of event A must not be 0. Otherwise we cannot make it. Probability of A should not be 0. If it is 0, we cannot make it. Division by 0 is not possible. That is the thing. Now let's try to say what are the different properties. One, maybe f of x given a minus infinity. What it will be? Tell me quickly.
0.
Yes. Whether it is conditional or not, it is CDF, right? So it will follow the CDF 0. And f of x given a at infinity, it will be 1, right? Now the second is it will be in between 0 to 1. F of x given a small x less than or equals to 1. This is CDF. It should follow the CDF thing. So for x1 less than x2, f of x given a x1 less than equals to f of x given a x2. That means it monotonically non-decreasing function. For x1 less than x2, probability of x1 less than x less than equals to x2 given a will be equals to probability, or could write fx of a given x2 minus f of x given a x1. Okay, so that's all. So these are the all probabilities, all the same, all same, because it is, even it is a CDF, so all the same formulas will be followed. Okay, now let's do some example. So example, suppose x is a random variable and suppose it is a uniformly distributed over the interval 0, 1. So if it is 0, 1, then what will be its fx? Fx will be fx of small x will be equals to 0 when x less than 0, will be equals to x when x less than 1, when x greater than 1. Okay, so now we want to find the CDF of x. So what will be the CDF of x given that x is less than half? Okay, or we could write differently, where we want to find f of x a small x will be what, where a is the less than half. Okay, what it will be? Can you do it? See, now we are going to conditional. So fx here, so it is unconditional. There is uniform distribution over 0 to 1. We know it will be 0 to 1 kind of 1, and CDF will be ramp function at 1. It will be 1. It will go on 1. Now what will be the CDF of f x given a, where a is a probability of getting less than half, x less than a half? Okay, so what will be this f of x given a? Can you calculate it quickly and tell me what it will be? Quickly, let's do it. Okay, time is also getting up, so this is the last example, let's say.
Sir, 2x.
2x in what interval?
Sir, between 0 and 1.
No. How it will be 1? If it is 0 and 1, then 2x
No, 0 and half.
2x cannot be because
0 and half.
0 and half. Okay. So anybody has any opinion? So let's try to find the solution. So f of x given x less than half small x will be equals to p of a given b. That means probability of x less than small x and x joint probability x less than not equals to less than half. Okay, and probability of x less than half, right? So now we need to see that for x less than 0 the event has the probability 0, and for x given half will be equals to 0 for x less than 0, and for 0 to half it will be simply x. So here denominator probability of x less than half, it will be definitely half, and probability of less than x up to half, it is x. Is it making sense to all of you, or I could not explain it? So you see, if it is not making sense, I'm again trying to explain. So this is the probability of x less than x and less than half. That means we know that probability of x 0 to 1 is the x. So what is the probability of x when less than half? Then it would be x only. And what is the probability of x when it is less than half? That is half only, because we go 0 to 1, it becomes 1. So half is the middle point. So it is half only. So x by half will be equals to 2x. But then for which region? We are going for 0 to half, not more than half. So x is in between 0 to half. So if we see, so then what it will be? So our f of x given a of small x will be equals to 0 for x less than 0, will be equals to 2x as we calculated when x goes 0 to half, and will be equals to 1 when x goes half. That means earlier our probability was like that, it starts from 0 and it goes up to 1, and then it becomes, so it was fx of it was fx of small x, and at this point it becomes 1 fx. Okay, and now the conditional thing will becomes 0 up to half, it goes 1. So, and after that this is half, it goes 1. So this one, this blue one becomes fx given a of small x, and this one is fx unconditional small x. Now you see the conditional CDF has changed to its shape, but as it is CDF property will remain, but see how it changes its shape. So already if you draw something event which is less than half, then there is no point of going beyond half. That is the physical interpretation. So at half only it will become unity, because already you have the full sample space is x is half, less than half only. So the same thing we are getting. Is it making any sense?